Objective A. Multiplying monomials. Number 1. 20y to the 4th times negative a y cubed. Both of these polynomials have only one term, so we're multiplying two monomials. When we multiply monomials, one key is to regroup your factors, because each monomial is a product, so you have to look at each individual factors that's in the product, and then we're going to regroup them based on their degrees, their variables, and how they look. First one, to regroup them, I will put the numbers together, 20 and negative 8, put them together, and then I'm also going to put the variable y together. We have y to the 4th times y to the 3rd, and put them together. Notice that I did not change or perform any calculation at this moment. I simply moved the factors around. There's one property that allows us to do this, which is the commutative property of multiplication, along with associative property of multiplication, which allows us to regroup. Once we regroup the factors, we're going to simplify. 20 times negative a, that's negative 160. Y to the 4th times y to the 3rd. We apply the product rule of multiplying exponents, keep the base, add the exponents, we get y to the 7th. And that gives us the result of the first product. Number 3. 1 over 4 k to the 5th raised to the 3rd power. This one, by definition of exponents, it's simply multiplying the base 1 over 4 k to the 5th by itself 3 times. So if you want, you could write it out, or you could distribute the exponent 3 outside into the inside, and raise each factor inside to the corresponding power. So that's what I'm going to do. First factor is 1 over 4. I'm going to raise it to the 3rd power. Second factor is k to the 5th. I'm also going to raise it to the 3rd power. And then we calculate 1 over 4 raised to the 3rd power. It's simply 1 over 64. K to the 5th raised to the 3rd power by the exponent raised to another exponent rule. We multiply the exponents. Keep the base. Multiply the exponents. We get k to the 15. Objective B. Multiply a monomial by a polynomial. For this part, all you need to do is convert the product of a monomial and a polynomial into different products of monomials. And the property that allows us to do this is the distributive property. For example, number 5. There's a 4n outside the pair of grouping symbols. So we simply distribute this 4n into every single term inside. Let me write out step by step. First product, 4n times 2n squared. And then we have plus 4n times negative an. And then we have plus 4n times negative 5. And of course, if you already know what you're doing, you could skip this writing and go straight to the multiplication. Now we have 3 products of monomial multiplying by monomial. We simply follow what we did in number 1 and 3 to further simplify. So this time I'm going to multiply right away. 4 times 2, that is 8. N times n squared, that is n cubed. Next pair, 4 times negative 8, that's negative 32. N times n, that is n squared. Last pair, 4 times negative 5, that's negative 20. And just n. So that gives us the product of number 5. Number 7, same idea. There's one term outside, 2 terms inside. We apply distributive property to get rid of the grouping symbol. This time I'm gonna multiply right away without writing it out. First, 9 times 2, that is 18. U times v squared, it's just uv squared. Next pair, 9 times negative 3, that's negative 27. U times u to the 4th, that is the same thing as u to the 1st times u to the 4th. We simply add the exponents, 1 plus 4, that is 5. Number 9. Number 9, as you can see, some of the terms, you have negative signs. Whenever you have negative sign outside, you need to be very careful because that will change the sign of every single term inside. Let's prepare our distribution by drawing these little curves. These curves will help you write down the products as you go through the expression. First pair, negative 3 times 3, that is negative 9. And then you have uv times v squared. That will give you uv cubed. Next pair, negative 3 times positive 2. That's negative 6. U times u, that's u squared. V times v, that's v squared. So notice that I'm looking at different factors in the monomial and I multiplied them separately. You could also multiply them all together, like uv multiplying by uv, which gives you u squared, v squared. So it's really up to you in terms of how you multiply different factors. Next pair, there is no coefficient in front of uv squared. If that's the case, you could put a 1 there. So we're going to multiply 1 by 8, that is positive 8. And then u squared times u, that's u cubed. V by itself, so it's just v. Last pair, 1 times negative 5, that is negative 5. U squared by itself, so it's just going to be u squared. And then you have v times v, that will be v squared. So notice that we have 4 curves before, and we ended up with 4 products in our first step. So that's one way that you could check whether or not you finished all the multiplication that you need to do. The next thing to do is, sometimes you might be able to simplify this expression further if there are like terms. Do we have like terms? Well, we do, right? We have u squared v squared. So the second term and the last term, they are like terms. We can combine them. What about the other 2 terms? They look very similar, but they don't look exactly the same in terms of the variable part. So they are not like terms. We cannot combine them. Let's copy the first term, negative uv cubed, with a coefficient of 9, negative 9. Let's combine the 2 highlighted terms. Negative 6 minus 5, that's negative 11. Copy the variable part, u squared, v squared. And then simply copy the very last part, au cubed, v. And that completes this problem. Objective C, multiply binomial. When we multiply binomial, there are usually 2 ways to do it as well. You could apply distributive property or FOIL to multiply horizontally. You could also multiply vertically. So I'm going to show you both ways. For number 11, I'm going to do the horizontal way first. When you multiply binomial by binomial, you could look at how many terms are there in the first polynomial. We have 2 terms in the first polynomial. So I'm going to multiply the first term in my first polynomial by every single term in the second polynomial. And then you do the same thing for the second term in the first polynomial. Multiply the second term in the first polynomial by every single term in the second polynomial. So this is using the distributive property for every single term in the first polynomial. And this method also applies if you don't have binomial but trinomial in one of these or more terms. Some other people might remember FOIL. Basically what I have over here, first 2 terms, 4x times 2x. Let me highlight this. This will be the first two terms multiplying, and then outer two terms, because these two terms are the outer two terms in this expression, and then you have inner two terms, and then you have the last two terms in each binomial. So that's FOIL. There's a limitation of FOIL, right? Because if I change one of them to trinomial, then FOIL doesn't work. So I would say distributive property. That's the way to go. Once we have these curves, then we're going to follow our curve and multiply. 4x times 2x, that would be ax squared. And then 4x times negative 9, negative 36x. 3 times 2x, positive 6x. 3 times negative 9, negative 27. Combine like terms. The middle two terms, they are like terms, so we're going to combine them. Ax squared, negative 36 plus 6, that's negative 30 followed by x, and then minus 27. For number 13, I'm going to use the other method, which is multiplying vertically. When you multiply vertically, it's just like how you multiply whole numbers. Let's write down the two polynomials, c plus 3d, and then c minus d. Multiply these two. When you multiply these two, just like how you multiply whole numbers, you're going to look at each part. In this case, we're looking at terms instead of digits. So the first thing you do is multiply 3d and d. Multiply these two. And then you're going to multiply c and negative d. So just make sure that you also include the negative sign. And then we're going to multiply c and 3d, and then c and c. So it's just like how you normally multiply whole numbers. Positive 3d times negative d, that will be negative 3d squared. And then c times negative d, that's negative cd. And then c times 3d, that's positive 3cd. Make sure you write it below c, the column c. And then c times c, that is c squared. So put a plus sign here. And then we're going to add it vertically. Drop down negative 3d squared. The middle two terms, negative cd plus 3cd, that is positive 2cd. And finally, you have c squared. So your final answer is this one. C squared plus 2cd minus 3d squared. And then there is actually a third method. The third method is basically the same way as the first method where you multiply horizontally. So I'm going to use number 13 as an example. The third method is using the area mode. Whenever you multiply polynomials, you basically first do a rectangle like this, and then we're going to divide the sides by the number of terms that you multiply. The first polynomial is c plus 3d, so that's two terms. Therefore, I'm going to divide my heights into two terms. So cut the heights into two parts. The polynomials that we're multiplying, the second one, c minus d, we have two terms again. So I'm going to divide my base into two parts as well. And then once you've done that, you're going to write down each term as the side length of these smaller rectangles. So c and 3d, that would be the first part. Second polynomial, c and minus d. So notice that I use negative d as the length of the smaller rectangle because negative sign is part of the term. After you finish this, then you simply apply the area formula for rectangles, multiply height and base for each of these smaller rectangles. C times c, that's c squared. C times negative d, that's negative cd. 3d times c, that's 3cd. And then we have 3d times negative d, that's negative 3d squared. And then we simply add all these four parts. When you add them, you could just look at like terms, or you could write them all out horizontally and see what are the like terms. So if you add them, we will have c squared, and then these two terms are like terms. If you combine them, we will have positive 2cd, and finally followed by negative 3d squared. As you can see, when we multiply polynomials, we have three ways: the FOIL way, or the distributive property way, the vertical way, and finally the area model way. Number 15. Find the product. So number 15, if you look at this one, we have monomial multiplied by binomial multiplied by binomial. It's probably easier if we just do the distributive property. And you could do it from left to right, or you could do it in a different order, because we are multiplying three different factors by commutative property and associative property. We could change the order of operations, we could change the terms. For this one, let's just do it from left to right if you want. So distribute 2n into 3n and also minus 1. We obtain 6n squared minus 2n. Make sure you still keep it as a grouping symbol. Second pair is 3n plus 1. That's the second polynomial. And then, as you can see, we have a binomial times binomial. So you could use FOIL, you could use the area model, or the vertical way. Let's simply use the area, not the area model. Let's simply use the distributive property. 6n squared and 3n, and then 6n squared and positive 1, negative 2n and 3n, negative 2n and positive 1. Once I down the curve, I'm going to multiply. So you have 18n cubed plus 6n squared minus 6n squared minus 2n. And notice that the middle two terms, they cancel out. And we simply have 18n cubed minus 2n. Alright. Number 17. Solve applied problems involving the multiplication of polynomials. A box factory makes an open top box from a piece of cardboard by cutting out squares that are x inches by x inches from each corner. The area of the base of the box is given by this particular expression. We write the area of the base without parentheses. So if you want to figure out why this formula or why this expression works, you could do a little graph of a rectangle and cut the corners and figure out why this is the expression. But our job is simply just simplify this. And you could use area model, you could use FOIL. So this example, since we just applied FOIL to number 15, I'm going to do the area model for this. So let's do the area model. It's binomial multiplied by binomial, so I'm simply going to cut in each side into two parts. Fill out the sides. We have 18, we have negative 2x, we have 12, and we have negative 2x. Let's multiply 18 by 12. That should give you 216. And then 18 times negative 2x, that's negative 36x. Negative 2x times 12, negative 24x. Negative 2x times negative 2x, that's 4x squared. And then we simply add all these four areas. The negative 36x and negative 24x, they are like terms. So when you add them, make sure you combine those two. And that's going to give us 216 minus 60x plus 4x squared. Alright, that's it for this section. Thank you for watching.